Okay, guys, wanted to talk a little bit about another big concept with the line of regression. That's called extrapolation. It sounds like a fake word. It sounds like the word guesstimate or something, but it is a thing. Extrapolation is definitely a real thing, it happens on page 164. Here's the example they give us: is they went to like a school, and they took the heights of some kids who were between the ages of 2 and 9. And so they compared their age to their height. And so from the 2 to 9 year olds, they had this linear pattern going on. So the 2 year olds are down here, and the 9 year olds are like over here. So as the age increases, the height kind of increases, and it followed this pretty straight line. And that's all well and good and all right. And they came up with a formula for it, and so they predicted the height. So the predicted height was all this stuff. And so you take this value and then 2.45 times the age, and that would give you, if you know the person's age, between the 2 and the 9 year olds, if you knew their age, you can plug it in here, and that would give you a good prediction of the person's height. Now the problem comes in when, what if you use this to predict the height of a 20-year-old? Well, that may not work. If you do the math, if you go through and actually do the math, this time I looked up the math ahead of time. If you do the actual math, you end up coming up with a person that is about 80.7 inches tall, that's about almost 7 feet tall. So a 20-year-old is about 7 feet tall if you use this linear model. And the reason why that we get such a weird answer, an answer that doesn't really make any sense, is because this linear model, this linear pattern, doesn't continue past this age right here. We used this model to talk about something that was outside of the original scope of the data. We originally had 2 to 9 year olds. We can use this all day to predict the heights of other 2 to 9 year olds. That's okay. But once we start doing things outside of the scope of this data, we can no longer rely on those results, because we don't know if this linear trend is going to continue. And what actually happens is they have this person in the book. They kind of zoomed out here, and now they have ages going all the way to people in their 30s and stuff. And so your height, so it looks pretty linear at first, but then all of a sudden, eventually people stop growing, and so they kind of reach a ceiling, and so now you only get the heights. No matter how old you get, you kind of stay the same height or start getting shorter as you get older. So what happened was we were taking this line and expanding it out really, really far, and choosing a point kind of way out here on the line, outside of the original scope of the data. And we can't do that. That's called extrapolating. We're not allowed to do that. We're only allowed to make predictions using the model within the original scope of the data. For more info on that, you can take a look at the key point on page 164. So the key point on 164, and that kind of says it all right there. So that kind of explains it really well about kind of what we have to think, what we have to consider when looking at extrapolation. All right, guys, hope that clears that up.